Hello calculus, welcome back. Here is our next week worth of videos. I'm going to talk to you today about implicit differentiation. So what is implicit differentiation? I think it helps us actually to know what the word implicit means. So implicit means something is implied but not plainly expressed. So let's look at an example of an implicit function. Or an implicit statement in math. I'll say statement rather than function because I'm going to show you a circle. So let's say we have x squared plus y squared is equal to 25. Now this is the graph of a circle. Let's go ahead and give it a quick sketch. It has a radius of 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. And a center at 0, 0. 2, 3, 4, 5. So here is our circle. And what makes this implicit is that y has not been solved for. Y is squared. So we are talking about y and x and their relationship to one another, but we haven't specifically solved for y. So what we're saying about y, we're implying but not plainly expressing something about the value of y. So when you have a statement that's not solved for y and you want to take a derivative, you can use implicit differentiation. Let me show you how that works. So we're going to use our example of a circle. And here's what we're going to do. This is example 3.68 in your textbook, if you want to take a look at that. Let's write that here. Example 3.68. So we're going to assume y is defined implicitly, so not directly, but defined nonetheless, by x squared plus y squared equals 25. And we want to find the derivative. We want to find the derivative of y with respect to x. So here's how we're going to do that. So we have this x squared plus y squared is equal to 25. And the first thing we're going to do is we're going to take the derivative with respect to x of both sides. And so that's going to give us this derivative with respect to x of x squared plus y squared is equal to the derivative with respect to x of 25. The derivative operator distributes like that. So this is going to give us the derivative with respect to x of x squared plus the derivative with respect to x of y squared. And that's going to equal the derivative with respect to x of 25. Now, 2 out of these 3 pieces we already should be prepared to deal with. I can take the derivative with respect to x of x squared, and I can take the derivative with respect to x of 25. So the derivative with respect to x of x squared, I can just use the power rule and get 2x. And the derivative with respect to x of 25, I can use the constant rule and get 0. But we still have, I'll highlight it in green, we still have this piece here. The derivative with respect to of x of y squared. So what's going on here is we are treating y as a function of x. So we know, let's go ahead and put this in green. Y is a function of x. x, and it's stated implicitly. And so what we want to do is actually use the chain rule here. So we're going to treat y as the outside function, and we don't know exactly what the inside function is. So first we take the derivative of that outside function, 2 times y. And then the inside function, that would be y equals whatever this is. We don't know what this is, but I know that if I take the derivative of some function y equals, then what I get, a notation I can use for that, is the derivative of y with respect to x. So the derivative of that inside function I'm going to replace with dy dx. And that's the derivative of whatever y is equal to. Okay, so now let's take a look at what we have here, at this beautiful statement. Now I have an implicit statement of the derivative. Because when we solve for the derivative, what we're really looking for, what we really want is we want what is dy dx. And so that's what we're going to do, is we're actually going to solve for this dy dx. The derivative of y with respect to x. So I'm going to go ahead and rewrite this all in one color and solve for that differential operator. 2x plus 2y, derivative of y with respect to x is equal to 0. So I subtract 2x from each side, and I have 2y dy dx is equal to negative 2x, and I divide each side by 2y, and I get dy dx is equal to negative x over y, and that would be my final answer. So that's one example. I'm going to show you another example because I think that's the best way to learn this. So this is in your textbook, example 3.69. So we have this function, x cubed sine y plus y equals 4x plus 3, and we want to find the derivative of y with respect to x. This is, I think, a better example because look at what we have going on with y here. It's inside the sine function and then outside here. There's no way to solve this neatly for y, but we still want to know the derivative. So this is a way that we can find the derivative without solving neatly for y. All right, so the first thing we're going to do is take the derivative with respect to x of each side. D by dx of x cubed sine y plus y equals the derivative with respect to x of 4x plus 3. Again, the derivative operator distributes just like how you like here. So we have d by dx of x cubed sine of y plus d by dx of y is equal to d by dx of 4x plus d by dx of 3. Okay, so now what I think is helpful for you guys is just to look at this like I have 4 mini problems, right? I want to know this derivative. I want to know this derivative. I want to know this derivative. And I want to know this derivative. So let's go ahead and take them one at a time. I'm going to start with this one, because I think it's the easiest one. The derivative with respect to x of a constant is 0. The derivative with respect to x of 4x is 4. The derivative with respect to x of y. Now remember, we're taking the derivative with respect to x of a function y. And so this just becomes the derivative of y with respect to x. Whatever that y function is, this is its derivative. And then here is, I think, the tricky piece. So we're going to need a little bit more room for that one. And remember, we're just going to have our equal sign here, and we're going to add these two. So all we have left to work on is this little piece here. So I have a product, so that means I'm going to use my product rule. So I'm going to take first the derivative of x cubed with respect to x, and I get 3x squared. Then I'm going to multiply that by sine of y. Then I'm going to add to that my function x cubed times the derivative of sine of y. Again, here we're going to have to use the chain rule for the derivative of sine of y. So the derivative of sine is cosine of y. And then we want to take the derivative of this inside function, this y, which will just be the derivative of y with respect to x. And that would be our derivative piece there. Okay, so let's add all of these pieces together. So we have, I don't want to use that. I don't like that marker. I only like this one. So we have 3x squared sine y plus x cubed cosine of y times derivative of y with respect to x plus derivative of y with respect to x is equal to 4. And just to remind us where all these pieces are coming from, all of this is the derivative of our first chunk. And then this is the derivative of our second piece. And this is the derivative of our third piece. And then we had a plus 0 out here, but we're not really writing that anymore because it's not that important. So what you might have noticed is that in our next step, we want to solve for the differential operator. Let's make it purple. So we want to solve for this dy dx here, but we have it in two places. So what we're actually going to do is use factoring and grouping to get that differential operator out. So the first thing I'm going to choose to do is move this 3x squared sine y to the other side. So now I have x cubed cosine y times the derivative of y with respect to x plus the derivative of y with respect to x equals 4 minus 3x squared sine y. And now these have a common factor of the derivative of y with respect to x. So I can actually factor that out and say now I have the derivative of y with respect to x of x cubed cosine y plus 1 equals 4 minus 3x squared sine y. And I can divide both sides of my equation by x cubed cosine y plus 1 divided by x cubed cosine y plus 1. And I get the derivative of y with respect to x is equal to 4 minus 3x squared sine y over x cubed cosine y plus 1. And that's our final answer there. Looks hideous, doesn't it? Don't be afraid to watch this more than once if you are struggling. Okay, this is going to take some practice. It's going to take some work to understand. In fact, I'm going to do one more example where we're going to find a tangent line. All right. And that's going to help us start to apply this derivative a little bit more neatly. Okay, so let's find the equation of a line tangent to y cubed plus x cubed minus 3xy equals 0. That's a y right there. at this point, 3 over 2, comma 3 over 2. So when we want a tangent line, we want to write the equation of a tangent line. The first thing we're going to need to know is we're going to need to find the derivative. So we want to find dy dx of y cubed plus x cubed minus 3xy equals 0. And we're going to use implicit differentiation here because I can't solve this equation for y. So whenever you can't solve an equation for y, that's when you want to use implicit differentiation. So I'm going to take the derivative with respect to x of each side. Y cubed plus x cubed minus 3xy equals the derivative with respect to x of 0. I'm going to distribute this operator here. So I keep talking about the chain rule, right? But I'm going to tell you a quick and dirty secret after I distribute this. And then the derivative with respect to x of 0 is just a 0. So I'm going to apply that right here. So first, what you do is you take the derivative of the function y, and you get 3y squared. And I keep saying, because of the chain rule, because of the chain rule, because of the chain rule, you write dy dx. But if all you can remember is, look, I see a y, I write a dy dx, that'll get you through the day, okay? So anytime you're differentiating with respect to x and you're differentiating that function y, throw this in here, throw that dy dx in here. Okay, and the derivative with respect to x of x cubed is 3x squared. And then the derivative with respect to x of 3xy is going to be a little bit different. So what happens here is we're taking the derivative with respect to x, but we're taking it of this function y. And so what you want to do is use our product rule. And we're going to treat this as the product of, let me get that highlighter. The product of 3x times y. So we're going to subtract. So I'm going to take first the derivative of what's in blue. So the derivative of what's in blue is going to be 3 times the remaining function in green. And I'm going to add to that the function that's in blue times the derivative of the function in green, which is dy dx. And all of that's equal to 0. So I claim we've done the hard part. Now what we need to do is we need to solve our function we need to solve for our differential operator here. So I'm going to do some algebra to collect those differential operators next to each other and to put everything else on the other side of the equation. So I have 3y squared, derivative of y with respect to x, plus 3x squared minus 3y minus 3x derivative of y with respect to x is equal to 0. Now I'm going to collect these two terms next to each other and put these two terms over here so that I can solve for the differential operator. So I have 3y squared dy dx minus 3x dy dx is equal to negative 3x squared plus 3y. I'm going to factor out my operator, dy dx times 3y squared minus 3x is equal to negative 3x squared plus 3y. And divide both sides by 3y squared minus 3x, 3y squared minus 3x. And so I get the derivative of y with respect to x is equal to negative 3x squared plus 3y over 3y squared minus 3x. I see here that I have a common factor of 3, so I'm going to go ahead and take that out. Derivative of y with respect to x is equal to negative x squared plus y divided by y squared minus x. So that's my derivative. Yay! That's the hard part. The next thing we're going to do is find the value of this derivative when x is equal, when we have the point 3/2, 3/2. So one notation that your book is using is it says, look, you can take the derivative of y with respect to x and then this line, 3/2, like this, 3/2. That means plug this point into your derivative and solve. So that would be saying take negative 3 over 2 squared plus 3 over 2 divided by 3 over 2 squared minus 3 over 2. And if you do that, you get negative 1. So this is the slope of our tangent line at that particular point. At our point 3 over 2, 3 over 2. So we can use that in our point slope formula to find the equation of this tangent line. So we have y minus 3 over 2 equals negative 1 times x minus 3 over 2. And that gives us my minus 3 over 2 is equal to negative x plus 3 over 2. Add 3 over 2 to each side. And we get y is equal to negative x plus 3. And that's the equation of our tangent line at that point.